Hi everyone. This video is part of a series of videos intended to provide a brief introduction to the features of SAS. Today we'll focus on Proc Geocode. We will use Proc Geocode to transform a dataset containing addresses into one that has latitudes and longitudes. That's the coordinate combination that allows us to pinpoint any address on a map. So you might ask, what is geocoding? Well, geocoding is the act of transforming a description of a location, such as an address or a name of a place, maybe a city or a zip code, into an exact location on the Earth's surface, and therefore it makes it easier for us to map it. Google Maps will allow you to find a point or a series of points on a map. However, you have to process that one at a time. In order to do more than that requires a higher level of service from Google than is currently freely available online. SAS, like some other GIS programs, GIS stands for Geographic Information System, allows you to do a lot of addresses at once, creating pinpoints on a map for many addresses at the same time in a batch format. Once that's completed, the result is typically stored as a geographic overlay, also known as a layer. These layers can be used for visualizing a new map feature for further spatial analysis. What are some typical uses of geocoded data? One typical use is locating existing or potentially new customers. This is very important for businesses. This helps in developing service delivery areas, market areas, and identify opportunities for growth. Companies like UPS, FedEx, and the United States Postal Service, they all use address data to help improve the efficiency of routing to reduce delivery costs. Geographic, demographic, and economic data are often used to help improve the effectiveness of marketing. Because marketing can be expensive, you want to make sure your brand message reaches the people most likely to be or to become your customers. Geographic visualization is helpful in the presentation of data that can be mapped. As you can see in the picture to the left, some areas of the city have property values that are astronomically high. If you're going to build a new office building in this city, this map could give you an indication of where property values are within your price range. Once you've mapped your data, you can use it to find patterns on the map. This may include finding or identifying geographic clusters. Geographic analysis may include measuring the impact of a local amenity on housing prices based on the distance the house is from that particular amenity. It could also include a map that depicts the geographic readership of a particular newspaper. In general, Proc Geocode is a SAS procedure that converts geographic data into geographic coordinates, like latitude and longitude. These geographic coordinates can then be used on a map to calculate distances or perform spatial analysis or any other number of different kinds of analyses that you need to do. By default, SAS has the data necessary to map the data to a state, to a county, to a zip code, and it has the ability to do other things as well. The geocode procedure supports 6 different methods of geocoding. These include geocoding to the zip code centroid, to the centroid of the 4-digit addition to the zip code, to the city center, and range geocoding, which is commonly used for IP addresses and geolocating computers. You can do custom geocoding, and you can also do street-level geocoding, which is what most of us are familiar with when we're working with things like Google Maps. Street-level geocoding is also the most complex of all the different types of geocoding that's performed. It returns the location of a particular address on a street. This method requires that you download a compressed file from SAS and copy it into a SAS library in order to use it. Basically, what you're doing is you're taking a data set that has addresses in it and adding in the latitude and the longitude based on that address so that it can be pin mapped to its location inside a geography. Here's some important terms that you need to keep in mind when you're working with this kind of data. We oftentimes refer to a layer. A layer is the visual representation of a geographic data set. For example, on a road map, states, counties, different types of roads, national parks, and political boundaries might be considered different layers on the map. Each one of those layers could be thought of as a separate data set. A polygon. A polygon is a closed area including the boundaries making up the areas of a map. A country, a state, a county, a zip code, all of these are examples that can be represented as polygons. A centroid. A centroid is often described as the polygon's center of gravity. In a regular polygon, you can form the centroid by taking the intersection of the medians of each of the sides of the polygon. For more complex polygons, the centroid is found by using other methods, and you can find this described in various websites and textbooks. We're going to start off by showing you how to geocode to a city centroid. This method uses the centroid of the nearest city as the basis for the latitude and longitude assignment. This method is generally used when the street in the address isn't found, because typically it's the least precise method that's available in SAS. The link below will allow you to download a data set, and the SAS code is given below. Proc Geocode can be given as one line of code. I've separated it into different lines so you can see what each piece does. As I said, this method uses the centroid of the nearest city as the basis for the latitude and longitude assignment. Geocoding to the city centroid is not very precise. Many rural addresses are associated with a city, but are actually not located within the geographic boundaries of that city. This method can assign the latitude and longitude relatively far from the actual location of the address. However, this method is often used when the underlying goal is to attach city or place level data for the nearest city to each of the addresses. If you download the dataset associated with a link in this page and place the dataset into your work library or some other library in SAS, you can use the code in the blue block to geocode to the city's centroid. Just make sure if you're not using your work library that you modify the code to indicate which library the data is located in. The next thing we're going to do is geocode to the zip code centroid. Zip codes are a system of postal codes used by the United States Postal Service since 1963. The basic format of the code consists of 5 digits. The purpose of the code was to sort mail into a progressively more precise location within the United States. The first 3 digits sorts to a sectional center facility for further sorting, and then the last 2 digits are used to send it to a specific post office for delivery. In the map to the right, several zip codes are shown. What we see here is that several zip codes cover parts of Carroll County, Georgia. Zip codes can be much larger than cities. However, cities don't cover all areas within the United States. Zip codes do. And so if you geocode to a zip code, you're guaranteed that the address will be located inside the boundaries of the zip code. Zip codes have also been extended more recently in 1983 to include a set of 4 additional digits, which further subdivides zip codes into smaller locations, into smaller areas. When we geocode to a zip code, we have to start off again with the address data. So here, the original address file, you can see the address, the city, the state, and the zip code. And then once we use the code to the left, which is exactly the same as the code that we saw before with one exception. The method now, instead of city, is zip. When we run that block of code, the new data set that's created has 4 additional variables in it. It has a Y and an X, which is our latitude and longitude. It has the number of observations that are geocoded to that specific location. And then it has the method by which it was matched. And in this case, because we used the zip code, the method was zip. As I said, zip code geocoding can be inaccurate, especially in rural areas where zip codes can be relatively large. However, an address that is geocoded by zip code is assured to always be located inside that zip code, unlike the city method. When you geocode by zip code, every zip code gets a centroid, and every address that has a zip code gets geocoded to the associated zip code. This may be adequate if you're using the lats and the lons to estimate longer travel distances, for example, zip codes in another state or another region in the United States. So if you're looking at travel distances between two faraway zip codes, it may be perfectly fine. However, geocoding by zip code in smaller areas will give you more error in the distance calculation. Street level geocoding is the type of geocoding that we're probably most accustomed to, but is the most difficult to accomplish. Street level geocoding uses multiple lookup data sets. Also, in SAS, additional variables are created to indicate the quality of the conversion and show what information was matched or found. Was it the street, the zip, or the city? Street level geocoding uses up to 6 different data sets to look up the information. 3 of those are already installed with SAS, but the other 3 have to be downloaded from SAS Maps online. These 3 related files are created from the U.S. Census Tiger line files. To download these additional data sets, follow the link below. There's instructions in the readme.txt file that tells you what to do with the data sets. The 3 most important data sets that you find are USM, USS, and USP. When you download them, you need to run a program in order to convert them to a SAS data set, and then once you've converted them, you move them to your SAS help library if you want to keep them permanently. Once they're available in the library, you can use the lookup street equals option to use these data sets to do the geocoding that you intend to do. So step 1, you need to download the data sets from SAS. Follow the link to find the file. This is what this website looks like. Click on GEOCODING, street level geocoding. Then select the data set that's the most recent one available. It'll bring up the actual download page, and you click on the zip file to download. Keep in mind, this is a pretty big file. Currently it's about 2.2 gigabytes compressed. So it's going to take a little while for it to download. Step 2, once the file is downloaded, you need to unzip the file into a folder that you can eventually connect to a SAS library for quick access. I stored mine in a folder that was on a different drive. Once you access the data set, this is what should come out of it. Once you access the zip file and extract it, these are the files that you should see. The README text, the import CSV files.sas, that's a program, and then several different CSV files to go along with that. You need to open that import CSV files.sas in your SAS 9.4 program editor. Once you open that file up, you're going to modify the path to include the location where you downloaded your data set and extracted it. The 4th step in this process is to determine how you want to save these files and how you want to store them. If you plan to use Proc Geocode on a frequent basis, specifically using the streets, then you may want to move the USS, USM, and USP files to your SAS help library. This is where the zip code data is also kept, so you'd be storing them in the same location as other files used in Proc Geocode. If you don't have a lot of storage space, or you're only planning on using these on an infrequent basis, what you may want to do is unzip the 3 files, put them into a folder, use a lib name statement in order to access them, and then after you finish using them, delete the extracted file but keep the zip file that you've downloaded for future use. Once you've extracted your file and you've run your import program, then what you need to do is run the Proc Geocode with the following modifications. In blue here, you can see that we've changed the lib name to include the location where those files are now located. So those 3 new files are located in C:/download streets on my computer, and I named the library streets. And so Proc Geocode, the method now is going to be equal to street, data equals work.address, the original file that we were working with before, but now we include lookup street equals streets.usm. And so USM should be stored in the streets library. The output is the same, it's work.geocoded. If we desire to keep some of the attribute variables that are available in that data set once we've geocoded, then we can list those variables here. And I've chosen to keep the county and the tract. And so you can see after running the geocode, I have a Y and an X. The Y is our latitude, the X is the longitude. So remember, the original file was the address file. We created latitude and longitude from those addresses based on the street level. We tagged each of the observations with other geographic information that's contained in the data set. And almost all the addresses are matched by street, but there are some addresses where the zip code was the only thing that we were able to match by because the street wasn't found. Once we've added a coordinate system to the data set, every GIS system out there, every geographic information system available, can take that coordinate system and pin map the results. One of the nice things is that with that pin map, we can now start doing some visual or graphical representations of the data that's contained in each one of those addresses. This can be used to understand geographic relationships that we can't immediately see when it's in tabular form. Here are some links to resources for Proc Geocode that will allow you to see a little bit more in depth of what Proc Geocode can offer. Thanks for watching.